All right, how's everybody doing? Okay, good, good, good. Okay. Hope everybody had a good break. It's good to see everybody. Hope you had a little bit of time off, got to spend it with family, recharge your battery. We have 4 weeks until the end of the semester. A couple things going to be happening through that. So your next quiz is going to be on Wednesday, and it's going to be over number sets, significant figures, and scientific notation. In fact, I think what we're going to go ahead and do is I'll give you the homework tonight. We'll go ahead and review over the material. I have the classwork as well. Have it due on Wednesday. We'll come in and talk about it. Go ahead and take the quiz. I also want to go ahead and give you some time this week to go ahead and work on your IA, which is going to be due in a couple of weeks. Remember, on December 13th. So I believe 2 weeks from this coming Thursday. All right, so tomorrow I'll have a list of expectations and things I'll be looking for, but definitely be looking for that checklist. Look to see, does your paper have this? Look at the criteria, all of that good stuff. But I want to go ahead and give you some days this week to go ahead and work on it in class as well. So I'm going to be giving you tomorrow. I'm going to be giving you Thursday, whatever class time we have on Wednesday after we talk about the homework and finish up with the quiz. I don't expect that would take too long. But if you want to bring your material starting tomorrow, if you just want me to look at your data, or if you're still kind of concerned about your topic, anything like that, we'll go ahead and take a little bit of time to go ahead and start to look at. The Chromebooks will be available. Really, this time will just be yours to go ahead and work on that IA. Has anybody already written their rough draft? Okay, it is due in just a little over 2 weeks. That's why I'm going to go ahead and start giving you time. I am going to record this as a test grade. Okay, so we do want to go ahead and you'll be taking a look at that, but just bring me any questions you have tomorrow. We'll kind of see how that works out. Now, as far as a real exam goes, next Friday on the 7th is when we'll have our official exam number 2. So this 6 weeks we are going to have 3 exams. The IA is going to count as one of them, but instead of 15% each, they'll be each 10%. So that'll kind of help out with the averages. I think that's everything I have, unless anybody has any questions. No? Everybody have a good break? Everybody looks excited to be back? Yeah. Good. I mean, we've only got 4 weeks till we're on break again, so it's going to go fast, especially, in that last week, because that's pretty much review, and then we have our 2 half days of finals. Okay. All right. But let's get to it. We have our next focus activity. Now, it's been a little while since we've seen one of these. Numbers 1 and 2 are still over here. There are a few copies left in case you have misplaced them or lost them, whatever the case is. But this is focus activity number 3. And we're bringing up normal distribution because it's been quite a while since we've seen that. And I thought it was a perfect opportunity to go ahead and refresh our memories and also help the people who were not here when we originally talked about it. So let's see. In 1972, the heights of rugby players were approximately normally distributed with a mean of 179 centimeters and a standard deviation of 7 centimeters. Find the probability that a randomly selected player in 1972 was. Now, if we're talking about this graphically, we know that the data is normally distributed. We like to look at the data within how many standard deviations of the mean. It's always 3. We go 3 above and we go 3 below, right? So here it's telling me we have a mean of 179. So for example, how would I get 1 standard deviation for this? Like 1 above and 1 below. What do I do? Just draw a line? Well, we draw a line, but how do I get the value? Yeah, it's even illustrated down here in these other sketches that I've provided to you. If you want to go above, say, 1 standard deviation, well, then you're just going to add whatever that standard deviation is. So 179 plus 7 would give me 186. And then if I wanted to go 2 standard deviations, then I would go what? 194. Okay, 194. Okay, would you guys agree? Why not 194? 193, there you go. And then we finish up with what? 200. So it's a little off right there, but you can see. Okay, 200. And then if you wanted to go in the other direction, what would you do with the standard deviation? You go ahead and subtract. If you went add to go above, well, then you're going to subtract to go down. All right, let me go ahead and write these sideways. So 179 minus 7. Let me see if I can write these sideways. 172, kind of. Okay. Now I need 172 minus 7. 165. Kind of. You can kind of see that, yeah. Okay. And then, last one, 165 minus 7. Okay. 150 what? 58. There we go. So like I say, it's not perfect, but I'm kind of trying to do it sideways, and that'll work out. Okay. Now, one other thing, don't believe it's coming up in these problems here, but we're going to go ahead and use the calculator to do this. But let's say we didn't have a calculator and we were doing this by hand. Remember, we're looking for the percentage of the area below the curve. Does anybody remember what percentage is between one standard deviation of the mean?
34%.
Okay, so Eli says 34%. Is he right? There you go, 68%, because each one of those sections was 34%. Okay, so in one standard deviation, that was 68%, so we had 34 and 34. I'm not going to write the percent symbols because I don't have enough room to go ahead and do that. All right, then what about within two standard deviations? 90 what? Well, it's been a while. 90, not 96. 90, 95. Okay, it was 95. Let me go ahead and do this one in red. And then we can go ahead and break this up. See, we've already got 34 and 34 for 68. Well, what's the 95 minus the 68? Okay, and I want half of that. Remember, that was 13.5. So this little area was 13.5. This was 13.5%. Okay. And then now, what was the maximum area we were going to say was below the curve? 99.7. Okay. It's within three standard deviations. 99.7. And does anybody remember what these little sections would be? Okay. 2.35. There we go. So this one is 2.35%. Remember, this one was 2.35. So it's been a while on that one. But does everybody remember? Okay. It's kind of coming back to us. Yes, ma'am. The area, it's a percentage of the data. Like if I were to go ahead and say, okay, now what's the probability of randomly choosing a rugby player who has height in centimeters between, say, 179 and 186? Well, then I could say 34. 34%. What if I said, okay, what's the probability of randomly choosing a rugby player that has a height between 179 and, let's say, 193? What would I do there? Between 179 and 193. Yeah, so 34 plus 13.5, what would that give me? Okay, makes sense, right? Now, that works great if you're dealing with values that are always following the standard deviation, but what if we're looking at values that don't follow that? That's when we're going to go ahead and use technology. Does anybody remember, I think we talked about having the possibility of my showing you this by hand, but I think we ultimately decided not to do it. Do you guys remember my talking about z-values?
Yes.
Okay. Yeah, and these long tables, it's just huge. I mean, it really is a lot of fun. Don't let me get you wrong, but I mean, it's just something we don't need to do in here for the paper exams. Okay, but Haley, is that making a little more sense? Okay. All right, so good. So we remember how to go ahead and sketch it. You know, we remember the percentages, but that's really good because it's been a while. So let's say given this, we're looking for the probability that a randomly selected player is at least 175 centimeters tall. So the way it could be notated for you, the probability of X being greater than or equal to 175. Okay. What's the percent that we're going to end up with? Now, do you guys remember how to do this using the technology? Okay. So let's go to our calculator. Okay. Now, where do I go? Do I even need to be on the scratch pad? This was from pre-calculus. Do I need to go back to my home screen? Okay, so we stay here.
Yes, and then you click
Menu. Statistics. Because remember, we're talking about normal distribution, right? Now, which one did we want?
Yeah.
We wanted normal CDF? Okay. Now, what is this?
So that's the boundary. So the lower boundary would be 175.
There you go. So on this particular problem, okay, we want everything greater than or equal to 175. So that means it's the lower boundary, right? So I'm going to come back over here. I'm going to type in 175, but there's no upper boundary. Remember, it was just 99999 all the way across. And it sounds silly, but it's just one of the things we do. Okay. And now, what's this mu mean? Did you get it? What does the mu mean? You know you missed it. What does it mean? It's the mean.
What you mean?
Mean. Yeah, I'm going to stop talking. So what was our standard deviation, or excuse me, our mean was 179. Okay. So 179, and our standard deviation was 7. Okay. So now I'm going to do this. I'll click OK. And there we go. So what's the probability? I'd say about 71.6%. Okay, close to 72. Okay. Does it say how to round? Nope, so I'll just go ahead and say 71.6. So about 71.6%. All right. Now, find the probability that a randomly selected player is going to be between 170 and 190. So the probability of 170 less than or equal to x less than or equal to 190. Now this one works out nicely because I have both what? Both an upper and a lower. So 170 and 190. So how did I get there again? I remember you said menu. Statistics, distributions, normal CDF, not PDF. Okay. And then our lower, what was our lower? 170? Okay. Then the upper was 190. Mean was still 175, right? 79. And then we had a standard deviation of 7. Okay. So what's the probability or percentage of getting a player between 170 and 190 centimeters? About 84.3%. Okay. Is this coming back to you guys? Okay. And Haley, is this making sense? Somewhat. Okay. Have you made it to these videos yet?
No.
Not quite. Okay. So 84.3, we'll say. So about 84.3. Okay. Now in number 2, where you see that notation where it says X, it looks like that little tilde symbol, you know, similarity recognized first and foremost from geometry. But this is just putting in notation what we verbalized up here. That just means the data is normally distributed. What's 30?
Mean.
30 is my mean. Now, 8 squared is my... That's the variance, yes. Now remember, when it's squared, that's the variance. But we always go ahead and write it as such. So that means my standard deviation has got to be 8. Okay. So we have the same information, but this one's a little different. What are we doing? It says the probability of x less than or equal to k equals 0.1. So what does that mean?
Are we trying to find the boundary?
Well, we have... Yeah, exactly the way you said that. Okay, I like that, the boundary. Because we are already given the percentage, right?
Yeah.
Okay, so we're going to have to use this information and just go a little different in our calculator. Okay. So I don't want to go ahead and say it yet. I want to see if you guys recognize it because we've passed it several times on the calculator. I'm going to come on over here. So let me document B out of this. All right, so we went to menu, statistics, distributions, inverse normal. See, if we have the percentage and we're wanting to work backwards, then we want inverse normal. If we're looking for the percentage, then we want that normal CDF. Okay. See, it's asking for the area, which I believe was 0.1. Okay. And then we had a mean of 30 with a standard deviation of 8. Okay. You about all right with that? Now I'm going to go ahead and click OK. So I'd say it's about 19.7. You could probably say 20 on that one.
Wait, is it the calculator not able to do the less than?
Be careful. Now this one is correct. Okay.
You can't do the more.
There you go. I'm glad you said that because we were right about to go into that problem. I was going to see if anybody remembered it. When you're looking at these types of problems, if it's less than, even less than or equal to, this is perfectly okay. Okay, that's perfectly fine. So I think we got about 20, 19.7. But that's a really good point. I'm glad you did. Anybody else remember that?
I knew about it.
Okay, Carolina, remember that? So here's the thing. Your calculator is only capable of doing the less than operation, so we're going to have to rewrite this one. Okay, only if you have the percentage and it's greater than do you have to do this. Remember, I'm going to say the probability of x less than or equal to k. What do I do? Where'd 0.4 come from?
Subtract 0.6 from.
There you go. Whatever you're given, subtract that from 1, which would represent 100%. Okay, but you only do it if it's greater than, because we can handle the less than. Is everybody okay with that? Okay. So now we're going to put everything in, but we want to make sure to use 0.4. Because otherwise the calculator is going to be telling you everything less than at 60%. Does that make sense? Okay. So let's see here. Go to menu, statistics, do distributions, inverse normal. But this time we put in, bless you, 0.4. We still have mean of 30 and a standard deviation of 8. So I'd say 27.97. I'd say probably 28%. 28%. Or excuse me, 28 is the value. I'm sorry, that's not the percentage. 28. And then we do need to go ahead and sketch these. So I wanted to go ahead and do the operations first, and then we'll sketch these. Hey, Eli. There you go. Okay, here we go. Whoop, would you pass that to him, please? So if we're looking at, the graph here, remember my mean was 30. So I'm going to put 30 right here in the middle. And then we have a standard deviation of 8. Okay, so one standard deviation above would be 38 plus 8. 46 plus 8. 54. So if we added to get the ones above, we're going to subtract to get the ones below. And see, it's minus 1 times the standard deviation, minus 2 times the standard deviation. So 30 minus 8 is 22. Minus 8, 14. And then minus 8, 6. Okay, so we got a value of about 20. Okay, so maybe right about here. So right about at 20, that would represent 10% of the data. Is everybody okay with that? It's been a while. All right, let's do the same thing on the other one now. I'm going to go ahead and fill in these values. We had 6, 14, 22, 30, 38, 46, and 54. Okay. All right. And what did we get as our answer? 28. So that's going to be really close to this one right here. Let's say that's 28 right there. Okay. So everything below the curve less than that mark, what we're saying is 28, is 40% of the data. Okay. Greater than is when you switch it. Yes.
But you would still shade it as the less than.
That's a good question. I would say because we're stuck with the less than, I would shade the less than. Shade that. That's what I would do. Now, I've never seen one where they have you draw one and then shade on the paper exam. I've seen ones where they provide the graph and then ask you questions about it, but I've never seen a shading one. Okay. All right, how are we doing? Good, good, good. So we remember that now? Good, good, good. Remember, this is a focus activity, so put that someplace safe. Okay, we don't want to lose those. Remember, you now have 1, 2, and 3. I've already got, I believe, 4 and a 5th one already printed up and ready to go. So as we go through, we'll get a few more of those. Good, good, good. You want to save changes? Yes. Okay. All right, now it's been a while, and I knew this was going to work out nicely. We had a classwork example, or page I should say, based off the notes that we finished right before the break. So I decided to wait on that because I figured this would be the perfect review the first day we got back. But I'm sure a lot of people, how many just went home and studied your math every day? So many hands going up. So many hands going up. How many people found themselves by the fourth or fifth day just having withdrawals because of the pun shortage and just had to go watch some videos to kind of take care of that? So many hands going up again. Oh my gosh. Okay. All right. Good. I believe I want slide 18. Okay. Well, let's go ahead and run through this together. You know, I'm big on the audience participation. I'll go ahead and get you guys up here to do a few of these. I'll do a few, and let's see how far we get. Okay. Remember to show work or provide an explanation for each problem. Problems with an asterisk require their answer only. So, number one, okay. Which number sets do the following numbers belong? Place should be check in the box for the appropriate column. Okay, so we have N, which is our natural numbers. We also call them cardinal in IB. Z is our integers. Q is our rational. Okay, all those that can be written in the form A over B, where B is not equal to 0. Okay, and of course R is my reals. Now, what do we know about every value that we come across? They're all what? They're all real. So at the very least, no matter what I'm given here, I can just go ahead and check everything off there in the reals. Don't have to worry about that. But now let's go ahead and check the other categories. 1/2. Is he a natural number? He is not. Now remember, your natural numbers are just your first counting numbers, like 1, 2, 3, and so forth. They went forward. Okay, so that does not have any fractions or decimals. Is it an integer? Now here's my question. Are the natural numbers or the cardinal numbers a subgroup, a subset of the integers? Yes. Okay, so the integers will have those positive counting numbers. We'll also have 0 and their opposites. But just like the naturals, the integers have no what? No fractions, no decimals. But is 1/2 a rational? Yeah, because by definition, it is a fraction. A over B, where 2 is not equal to 0. Okay, pi. Sure, we had a lot of this over the break. You know, it's a dangerous time of year for a fat man like myself, so I think I did pretty well. I was able to maintain below 200s. I'm kind of, you know, like the people who I taught last year, have you noticed? I'm down 56 pounds. Haley's like, I don't know. There, thank you so much. Math helped me through that. Okay, is pi a natural number? No, it is not a natural number. Is it an integer? No. Is it rational? It is rational. Yeah, you can write it as a fraction. And of course, it's real. In fact, what is pi? 3.1415926535897, and we can keep going, right? Sure, a lot of people can keep going, right? Obviously. Okay, what about 4? Is it a natural number? Yes. It is one of the first counting numbers you ever learned. Is it an integer? Yes. Can it be written as a fraction? Yes. And it's obviously real. Okay. What about negative 8.7? Is it a natural? No. Is it a integer? No. Is it rational? Yes. Okay, remember the rationals do allow decimals and fractions, okay, because they're going to be equivalent to each other. Okay. All right, good. Now, I didn't have the calculators out today because I didn't think it was going to be necessary to go ahead and have them. We can just use the calculator I have up here. So number 2, it says a square has an area of 67 square centimeters. Okay. Find the length of one of the sides, giving the answer to an appropriate number of sig figs. Okay. Well, how would I go ahead and find the side length of a square if I know the area? Yeah, take the square root because it's side times side for a square, right? So I'm going to come on over here. Let me go ahead and get out of the normal distribution. The square root, what was it, 60 what? 67? 67. All right, so 8.18535. Now, it just says to an appropriate number of decimal places, or I should say significant figures. How many were we given when we started? 2, so I would probably go ahead and stick with what they gave me. So what would that be to 2 sig figs? 8.2, yes. So 8.2 centimeters. There we go. Okay. All right, let's try number 3. Now, it's got the asterisk, so all we need is just the answer. So it says, go ahead and calculate this expression exactly, correct to 2 decimal places, and then correct to 3 significant figures. Okay, so I'm going to go ahead and type this in real fast. So 2.5 parentheses, and I forgot about 6.42 squared. 3.54? And then that's close parentheses, right? Was there anything else? Okay. Now, it says this number exactly. All right, so let's just go ahead and make sure that there aren't any hidden decimals that I don't see. So now we're good to go. 94.191. Okay. Now it says correct to 2 decimal places. So that means to the nearest what? 100th. So I want 2 places. So how would I write that? Okay. Now it's say 94.19. Because we want it to 2 decimal places. As Spencer said, that's the nearest 100th. Is everybody okay? All right. Now, what's the difference between that and correct to 3 sig figs? So, Sierra, what would that be? Okay, so what would the actual answer be? 94.2. There you go. There you go. And you guys remember that little strategy I had for the significant figures? If you're looking at America, P and A, Pacific and Atlantic, if the decimal is present or the decimal is absent. So do we need to kind of go over that again? No? Okay. How's everybody doing? Good? All right. The fraction 22/7 is often used to approximate pi. You've probably seen that. You know, some other teachers use that from time to time. I personally don't ever do that because I know it's not an approximate. But to how many significant figures is this accurate? Remember to show work or give an explanation. Okay, so let's go ahead and do this. Who in here knows pi to more than, say, 5 decimal places? I say 5 would be careful. Carolina, what is it? Perfect, I like it. Okay, so pi 3.141592653589323. Yeah, and we can keep going, right? Because I'm just awesome like that. It's really good for an icebreaker at parties. Because I'm sure if someone walked up to you and just started rattling off pi, you'd be like, yeah. Tell me more. Oh, you haven't stopped. Okay. Okay. All right, so here's pi. Now, what we're going to go ahead and do to kind of show some work here is use some good old-fashioned long division. You guys remember how to do this? Okay. So I want to take 7, which is my divisor, and I want to divide it into 22, which is my, starts with a D, dividend. The answer I get is my quotient. Very good. All right. Would anybody want to come over here and show me the long division? So many hands going. Okay. Spencer? I mean, personally, that's why I wear glasses on problems like these, because it helps me with division. It helps me with division. Well, they're all good, right, Haley? There you go. I know you missed it. You know you missed it. Like, wow, I've come back already. Okay, so 3 gives me 21. And he's just going right into it. You'll notice he went ahead and put the decimal point, and he's now bringing down zeros. Now let's see here. You got the 3.14, so you got the 28 to. So yeah, you're right. And then 7. Oh, it's a Monday. No, you're fine. You're fine. 8, 56, 4. But you'll already notice what's happened. There you go. So the approximate value, 3.14159, when we divided 7 into 22, we got 3.1428, and then it's going to keep changing, right? So what would you say your answer is to this problem? 22/7 is only good to 3 sig figs. Okay. That is exactly right. Good. 3 sig figs. Okay. Number 5, write down the smallest possible length of a line given as. Now here, even though it says smallest length, why don't we go ahead and actually write out the compound inequality, because this is something that we talked about right before the break. 4 centimeters to the nearest centimeter. So what's the smallest unit of measurement that we use for the error? Does anybody remember? It's equal to plus or minus what the unit of measurement? 1/2. Do you guys remember that? Plus or minus 1/2 the unit of measurement that we have. Okay, so here let's go ahead and say, x. Remember, the lower was less than or equal to, the upper was less than. We don't have equality because we don't want it to round up. But what would be my lower boundary? 3.5, 4 minus the 1/2. And what would be the upper? Okay, 4.5. All right, do you guys remember that? Okay. Now remember, on the next one, there was something we wanted to take into consideration. Okay, even I totally forgot about this, and remember, I corrected my mistake. But now it says 3.0 to 2 significant figures. What am I referring to? Because we have the 0.0, if the number is given to me as a decimal, in this case, I need to take plus or minus 1/2 of what? 1/10. Okay. Plus or minus 1/2 of 1/10. Okay. And if I were given a decimal that was like 4.56, and I wanted to do this, then it would be plus or minus 1/2 of 1/100th. Yes. Okay, not just the zeros. If it's a decimal, you want to think about those places. Okay, so 1/2 of 1/10 is actually 1/20th. Okay, so let's just go ahead and do the thing like we did before. So I'm going to go ahead and put x in the middle, less than or equal to less than. Okay, so 1/20th actually comes out to what decimal? 0.05? Okay. So what would my first one be? 2.95. 2.95. And then, of course, 3.0 plus 0.05. 3.05. Okay. So remember, if it is given to you as a decimal and they're wanting you to do this, you have to consider those number of decimal places. Okay, even if it doesn't have a 0, and I forgot that myself. Okay. Good. Number 6. Which of the following equations have solutions that are members of the set Q? What's Q? Remember, that was rational. So by definition, it could be written as a fraction. Okay. To show work, solve each equation, and then categorize the solutions. Okay. So 2x minus 3 equals 1. Well, why don't we go ahead and get some folks up here to solve some good old equations. Who wants to solve this one? Just a linear two-step function. So many hands going up. You think with the whole week you were off, man, people would just be crawling over each other like it's Black Friday. Zoe? Oh, were you just putting your hair back, or were you raising your hand? There you go. She says I was raising my hand. I was not pulling my hair back. All right. Are you folks wanting her to actually run through the process of solving it, or just put the answer? Solve it? Raya would like Zoe to solve it. There you go. So 2x equals 4. There we go. Yeah, so it doesn't always recognize the inputs. So x equals 2. So which of the following equations have solutions that are members of the rational set? Would this be a member? Yeah, this is a rational number. You can easily put 2 over 1, still have a fraction. Okay. It's also a natural number. What else do we call it? Cardinal number. It's an integer. Okay. Good. It's also real. All right, B, x squared equals 6.25. Who would like to do this one? Okay, Zoe, who would you like to see do this? Araya. Okay, now this one's pretty straightforward. We probably don't need a calculator for this. Araya, what's the square root of 625? Okay.
What is it?
Okay, so it would be 25, but then we apply the decimal, so it would be 2.5. Yes. Now, how do we get that 2.5? How would I solve this equation? Square root it. Okay. So Araya got to the root of the problem.
Do you want me to?
Well, I'll just say yes or no. Is it rational? Would this belong to the rational set? Yes, it would. Sure. All right. Okay, so x equals x plus 7. Okay, so we're going to subtract x. Good. Okay, now my variable's dropped out, and we have a false statement. So that is definitely not rational. Yes, there is no solution to that equation. Hello. Oh, and I think yeah, I've got one. Yes, go right there. We go. And if you'll just put that in the tray, ladies. Don't forget to put your probability review in there as well. Okay, good, good, good. And our last one here, number 7. Einstein's formula for the amount of energy, E joules released when matter, kilograms is destroyed in a nuclear reaction, E equals mc squared, okay. Where c is the velocity of light, that means the speed, at 3.00 times 10 to the 8th meters per second. Find the energy released when 0.2 kilograms of matter is destroyed. Okay, so this one's just plugging into your formula. Okay, in fact, who was it? Libby, you were up last? Who would you like to see do this one?
We'll go with.
Okay, Louise. So when they're giving me that 0.2 kilograms, is that representing E or M? That 0.2 kilograms, is that representing the variable E or M? There you go. It's representing m, the kilograms. All right, so let's go ahead and plug into the formula. So E is equal to 0.2, and then times what? What's the velocity of light? Yes. We go with that. Times 3.00 times 10 to the 8th. Are we forgetting anything? Squared. There we go. We need to square the velocity. That's scientific notation we just put in. Yeah, that whole expression, quantity. There we go. And then squared. Okay, good. I'll tell you what, I'll go ahead and type this in for you. So let's see here. Let me go ahead and do that. So we had 0.2 times 3.00 times 10 to the power of 8. Okay, that's not what I meant to do. Let me get LR. And then we wanted to raise that to the second power. Okay, the energy released is equal to m times c squared. Would everybody agree? Okay, so it's going to give me... Now, what does this mean? What's that E mean? Yeah, see, that's already providing it to me in scientific notation. So I just need to put 1.8 times 10 to the 16th. There you go. Perfect. Thank you, Louise. I'll go ahead and write that down. Perfect. 1.8. Oh, this is your lattice diagram? All of these should be the sums. Like if you roll a 1 and a 1, you'd get a sum of 2.
Oh, I did not understand.
All right, so what was it? 1.8 times 10 to the 16th? Okay. Good. 207. Perfect timing. In fact, let me go ahead and stop this.